the Anthropocene is not a new basin of attraction. It's not a new equilibrium state. It's a pressure. It's that we, anthros, Greek for humans, are now we're sitting in the driving seat, totally running the planet. We're posing this global scale pressure. The big nightmare is the moment the Anthropocene goes from pressure to state. Because what that would mean is that the planet has crossed so many tipping points that it becomes dominated by self-amplifying feedbacks. Now it's still dominated by dampening feedbacks. And this is what we're scientifically deeply engaged in now to explore.
Hello, I'm Herb Simmons from the Climate Emergency Forum, and I'm here today, and I'm delighted to be here today with Johan Rockström, who is the director of the Potsdam Climate Institute, and we're on site in Exeter at Exeter University at the Global Climate Tipping Points Conference, a major conference that brings together academics and practitioners from all over the world to deal with what is one of the most critical issues we face, which is the extent to which tipping points, irreversible or not, may be part of our future, and how we can address them through what are called positive tipping points. And Johan, I really wanted to ask you, what is your role? You've been a leader, you've been an initiator of the whole effort to define and explain and analyze planetary boundaries. What's the status of planetary boundaries, your work? What do people need to know about it? And how does it relate to the Tipping Points Conference?
Yeah, no, thanks. And great to be with you, Herb. And well, the planetary boundaries come from the evidence that we are not only in the Anthropocene, but we're deep into the Anthropocene, but we're starting to see more and more signs that we are, at this top of these hockey sticks of exponential pressures on the planet. So we're trying to scientifically define what are the environmental processes that regulates the stability, the resilience, and the life support on Earth. And the reference point is to keep the planet as close as possible to Holocene equilibrium state, because we know that the Holocene, the last 12,000 years since we left the last ice age, is the only state of the planet we know for certain can support the civilizations of the world as we know it. And we've now been able to quantify 9 planetary boundary systems. These are the 9 systems that we are quite confident today regulate the state, the health of the entire planet. 6 of the 9 boundaries are outside of the safe space. So we're really in danger. And scientifically, to answer your question of how planetary boundaries link to tipping points, scientifically, to quantify the safe operating space for all the boundaries, one line of evidence is tipping points. So to put it simple, the boundaries are set to avoid crossing tipping points. So if we stay within the safe boundaries, so within the safe operating space for climate, biodiversity, for fresh water, for nitrogen, phosphorus, air pollutants, chemicals. You have 9 large systems that all together is the scientific evidence of keeping the planet in a stable state. We then have a good chance of avoiding crossing tipping points. Exceed the boundaries and you enter first a danger zone, which is the uncertainty range in science. And then you enter a red high-risk zone where the likelihood of crossing tipping points increase significantly. So it's a really integrated framework that gives us, let's say, a dashboard or a navigating chart to be able to, go through this gauntlet of avoiding to fall over the cliffs and trigger tipping points. So they're very complementary.
And I guess if we weren't close to reaching tipping points, or perhaps even on the barriers there, we probably wouldn't need a conference like this. I mean,
absolutely.
In other words, the true wish would be to say, this is our last tipping points conference, we've solved the problem. Obviously, we're nowhere near that.
No, exactly.
Say the least.
I mean, the latest science shows, and that is the state of the art at this conference, that we have identified 16 tipping element systems that regulate the climate system. So there are actually many, many more tipping points if you just think of freshwater systems and ecological systems on land and marine systems. But the tipping elements that regulate the climate, there are 16 of them as far as we understand today. And of those 16, 6 of them are likely to cross their thresholds or their thresholds, which gives us a tipping point already at 1.5 degrees Celsius. So that's why we've placed the safe climate boundary slightly below 1.5. And not only that, so those 6 is like the Greenland ice sheet, the West Antarctic ice sheet, abrupt thawing of permafrost, collapse of all tropical coral reef systems, collapse of the Labrador Sea Current, and collapse of the Barents Sea ice. So we're talking big climate regulating systems that if they cross their tipping points, they would go from a state where they today are dominated by feedbacks that dampen warming, so they cool the planet, to a state where they would actually amplify warming. So it's very dangerous. It's not only that crossing a tipping point means impact on livelihoods and potential, environmental impacts. You would also cause the Earth system to go from friend to foe, that it would self-reinforce warming. And this is why we need to be very careful with tipping points. And the second conclusion, which I've been trying to emphasize quite strongly here, is that if you take one of these tipping elements, is the Amazon basin. So this is, planet Earth's richest biome on land with regards to biodiversity. It recycles moisture. It is a carbon stock, which basically, if it would disappear, would consume the entire remaining carbon budget for an orderly phase out of fossil fuels. So it's a big thing. Now, climate science sets the thresholds for the Amazon basin at roughly 3 to 5 degrees Celsius of global mean surface temperature rise. So not so high risk. I mean,
for now.
But when you bring in the other planetary boundaries, when you bring in biodiversity, when you bring in fresh water, and when you bring in deforestation, then the temperature threshold goes down to between 1.5 and 2, for the simple reason that you weaken the system. So the planetary boundaries, not every boundary has tipping points, but they are quantified based on what contribution do they give to the resilience of the planet's ability to stay strong in the face of climate-related stress, for example.
So essentially, you've got all these individual tipping points, but they're all interacting in ways that we know and ways that we don't know, in ways that you at Potsdam and other places are trying to figure out and learn as these systems sort of migrate into new states that we haven't had experience with.
No, and this is the one of the, we put out a paper a few years back where we asked the question, are we at risk of knocking the planet over a large enough number of tipping point systems that the planet would go from friend to foe and self-reinforce warming, so we would push ourselves towards a hothouse Earth state.
Right, yeah.
And what is the hothouse Earth state? It would mean that it's important to recognize that despite all the risks we're facing and despite all the unsustainable pressures, and the 6 of the 9 boundaries are breached, the planet is still overall remarkably resilient. And my conclusion, at least so far, is that we're still living on a planet which is in an interglacial Holocene basin of attraction. We're wobbling. The cup is very shallow, and it can roll out very easily, but we're not yet outside of the Holocene. So the Anthropocene, when we talk about the Anthropocene is not a new basin of attraction. It's not a new equilibrium state. It's a pressure. It's that we, anthros, Greek for humans, are now we're sitting in the driving seat, totally running the planet. We're posing this global scale pressure. The big nightmare is the moment the Anthropocene goes from pressure to state. Because what that would mean is that the planet has crossed so many tipping points that it becomes dominated by self-amplifying feedbacks. Now it's still dominated by dampening feedbacks. And this is what we're scientifically deeply engaged in now to explore. Where is that threshold? And what happens if we have an Amazon tipping point and permafrost tipping point and perhaps 1 or 2 more? Would that be enough to kind of push the planet irreversibly on a journey away from a state? Because if we would fall out entirely of an interglacial state, then we would be, at a 3, 4, 5 degrees Celsius warmer planet, which would be unlikely to support anything that we define as
civilization as we know it.
Exactly.
Yeah, and I guess there's the risk of, will we even know if and when we've reached this sort of unstable new state, if you will. In other words, the lags in knowledge and just, the complexity of these tipping points. Because people, from what I understand, people are debating, have we crossed the tipping point? Have we not crossed the tipping point?
Yeah, this is something that really concerns me, that, admittedly, and we scientists need to stay true to our methodologies and our findings. And so unfortunately, we cannot give that there's no exact precision.
Right.
For the simple reason of the complexity of the system and the inertia of the system. So there will always be uncertainty ranges. And this is something that we need to stay true with.
Yeah.
But on the other hand, many in the receiving end misuse that information.
Exactly.
And use that as an excuse for not doing anything, or an excuse for questioning the results, or an excuse for just kicking the can down the road. And that's why I'm trying increasingly to say, look here, let's single out in this whole, normal distribution of complexity in the science, let's single out where we are in complete agreement, and where do we have high confidence. And for example, tropical coral reef systems, the uncertainty range is so narrow that we can say with almost with 100% certainty that go beyond 1.5 degrees Celsius over several decades, and the tropical coral reef systems will very likely not cope with that. And these are the kind of certain statements that we now need to start being more clear with, because otherwise, I agree, it tends to be that we are kind of allowing ourselves to continuously land in this uncertainty range. On the other hand, I think the world should be able to be guided by precaution. We are able to think of insurance. I mean, think of buying insurance for your house. You don't buy an insurance for your house because you're certain that the house will burn down. That there's a huge uncertainty range, luckily.
Right.
But you still buy an insurance because you're precautionary. And I think
if you're not inclined to buy it, the bank will require you to buy it to give you a mortgage.
Exactly.
To protect their interests.
Yeah, exactly. So nobody wants to take a risk, even though the likelihood of occurrence is very low, uncertainty range is wide, but still we act. And we act, of course, why? Because impact is unacceptably high.
Yeah.
So risk is something very different to probability. And so risk is equal to probability or likelihood of occurrence times impact. That's why I'm trying now on tipping points to communicate or remind anyone who wants to listen that if the impact is infinitely high, meaning unacceptably high,
existentially high in some cases,
then even if the probability of occurrence is low, take a low number, multiply by an infinitely large number, you get a large number. Risk is high.
Right.
So AMOC, for example, the shutdown of the whole overturning of heat in the North Atlantic, which would have catastrophic impacts on the entire world, even though science is uncertain, because the impact is essentially completely unacceptable, the risk is high. So we should act on it. We should act on it now.
So segueing then to my next question, which is, you've had the planetary boundary framework for a number of years now. You personally have been, I've seen you speak all over the world, and I'm sure your colleagues and so forth. Have there been any national governments or regional entities like the EU that have begun to embrace the planetary boundaries framework and attempt to meld their policies to be consistent with it?
Yeah. Well, not as much as you would wish.
As you would wish, right.
But you should know that, in the European Union, at the EU Commission, there is a planetary boundary unit today.
Okay.
You have countries like New Zealand, the Netherlands, Switzerland, the Nordics, one of the states in Germany that have used the planetary boundary framework to translate it to a kind of policy framing. You have cities like Copenhagen, Amsterdam, using the planetary boundary framework as well. So it is definitely happening. And in Switzerland a few months ago, there was even, they have direct democracy in Switzerland, so you can have citizen-initiated national elections or votes on questions. And one of them was, should Switzerland adopt the planetary boundary science as a guiding framework for the country? And there was a national vote. Unfortunately, it got turned down. But it was interesting that you had over 100,000 signatories, because once you have more than 100,000 citizens asking for a vote, then you get
it goes on.
And so we're seeing clearly a momentum there.
Well, that's very promising. I know you have to go soon. I want to ask you two other questions. If I could, I don't know if you were here yesterday when Oliver Morton gave a talk where he was basically saying that the tipping points community should become more open. Maybe I'm hopefully paraphrasing him accurately, to initiating, or at least looking at the role of solar radiation management as one of the elements that may be able to reduce the risk by lowering temperatures. I'm just wondering if you had any personal or other thoughts on that, whether from Oliver's comment or just from my question to you now.
This is a big question. You're opening a can of worms here. And I have great respect to Oliver Morton.
Right.
And I understand where it's coming from. And I also recognize that we will see more calls for geoengineering, given that we are so close to 1.5 degrees Celsius, and also that we are heading towards overshoot. So 1.5 is still, I would argue, an open, we can still land at 1.5, but it's getting really dangerous, and we're likely to have overshoot. So of course, the calls for radical engineering solutions will come, and I can understand that it is coming. But is solar radiation management an option? And the answer is no, it is not. And for the simple reason that we simply do not understand the unexpected side effects. And the side effects are likely to be catastrophic in themselves. And this has to do with the unexpected impacts on the global hydrological cycle, how it impacts on regional rainfall patterns, how it can fundamentally, shift the energy balance on planet Earth in completely unexpected ways. And nobody knows how to govern something like this. And so there are many reasons to be extremely careful with large-scale geoengineering options. And the second reason to be very skeptical is that it allows the world to release the little pressure we have on that accelerator,
moral hazard,
on decarbonizing the global economy. And if you think of the ocean, for example, solar radiative management would not solve the fact that we're heading towards collapse of many of the marine systems because of ocean acidification. So you have to be careful. It's not only about heat, it's also about chemistry. And so I think there are many arguments here for precaution. On the other hand, carbon dioxide removal technologies, for example, which is what I would call more gentle geoengineering, is absolutely necessary. We cannot come back to 1.5 without removing carbon. So we need carbon capture and storage. We need direct air capture systems. We need technologies to plug back the carbon where it came from. Those are technologies that are possible to deploy. They have manageable risk, and it's in a completely different category.
Yeah, and in fact, if I'm not mistaken, there are large-scale ecosystem restoration approaches that can both pull down carbon dioxide and also cool, at least locally and regionally, because of the increased, greenery and cover and so forth.
Absolutely, and they should be invested in and deployed. I would put those in the category of nature climate solutions.
Right.
The thing that is important to recognize there is that we need them. They have to be scaled. We need massive investments in them, but you cannot use them as an offset for not reducing your coal, oil, and gas. It has to be additional to whatever you do. And one reason for this is actually that in the climate models, giving us the remaining carbon budget for an orderly phase out, all the net zero pathways, they have already factored in assumptions that we will be successful with nature climate solutions.
I see. So if we don't do it, we're doubly harmed.
Exactly. It's a double counting risk.
Well, very last question. Really appreciate your time. So, this year is the 30th COP, and it's in Brazil, given nature and the Amazon. What are your expectations and those of your colleagues, Tim Lenton and others, for the role and the opportunity for COP to embrace and incorporate the planetary boundaries and tipping points in their deliberations and decisions?
I think we have a great opportunity in Belém. We have a COP presidency really expressing clearly that they want to raise science to a new level. We are providing that service, and we want science to be very close to the negotiations and really influence the negotiations. We've always wanted that, but here we have a presidency that really wants to accomplish that. We have a presidency that recognizes that you have to take a whole Earth system approach to solve the climate problem. We have a presidency, I hope, that really understand that number one task is mitigation, phasing out fossil fuels, and number two task is to keep the resilience in the biosphere intact. Put those together, and we need a planetary boundary framework. And I hope that that is where we will start that COP, and that the COP then aims at getting serious about delivery against science-based definitions of what needs to be accomplished, which we know is a zero carbon global economy within the next 20 years.
Cheers. Well, that's something I share your hope. I know most of our viewers will share that. People want more information. Can they go to your website at Potsdam or otherwise?
I would guide them to, we have something called the planetaryhealthcheck.org.
Okay. Planetaryhealthcheck.org.
Yeah, which is at the Potsdam Institute. And then we have, of course, you go to the Potsdam Institute's homepage and we get both the climate impact assessment, the scenario analysis. We do many of the scenario analysis, Paris Alliance scenarios, which are updated, all the time. So
okay,
welcome to have a look at that.
Well, thank you so much. And thank you for your amazing work on behalf of the planet.
Well, thanks for great about. Thanks. Okay.
Thank you so much, Johan.
Good.